charge that is enclosed within. This is the law of Gauss, and it shall not be broken.
Powerful.
MashaAllah.
My brother. What was it the other day? You know how TikTok knows
Okay.
everything you're saying?
Yeah.
Can we just accept that and move on?
Yeah.
Great. So the other day, I thought of something, okay? Something very specific. I didn't write it anywhere. Not even on pen and paper. I never spoke it out of my mouth. The thought never left the output of my brain. I did not output it in any way.
Yeah.
I opened TikTok and it's the very first TikTok.
That's terrifying. That's terrifying.
Because it's reaching a point where based off the content that they show you, the algorithm can predict what
What you're
your next
thinking.
thought is gonna be
Yeah,
based off what you consumed today.
that's some like mind
Especially
control
based on how
shit.
long the video played for and seeing how quickly you swipe away when it's finished, it shows them you actually did watch the whole thing. Because if you just let your phone sit, you wouldn't swipe away immediately. Do you know what I'm saying?
Yeah.
So they have ways to tell if you actually absorbed the info or not. So then based off that, they can tell how much of that is incorporated in your current line of thinking.
Target was sending advertisements to pregnant women.
Oh, this one's fucking crazy. That story's
Yeah.
crazy, bro.
They were
There's a
sending
woman who
targeted advertisements to pregnant women
Uh-huh.
with like baby stuff, okay? And they were so efficient at figuring out if a woman was pregnant or not that they would send it out before she told people, like members of her family.
Oh my
So-
god.
You didn't tell it well, bro. You ruined it. You didn't tell it well.
She got the advertisement from Target before she told her dad.
Oh
Wasn't
my
that a-
god.
And her dad,
Sorry?
That was a team pregnancy.
yes.
It was a teen
And
pregnancy.
her dad marched up to Target and fought the manager, and he apologized for the
Yeah,
inappropriacy.
no, the father goes up to the Target. He's like, why are you sending this stuff to my daughter? Like,
Are
it's
you
inappropriate.
suggesting that she should go get pregnant?
Yeah, exactly.
And
Yeah.
then 2 days later, he comes back. He's like, "Oh, I'm sorry. It turns out she actually was pregnant."
The AI
Shit.
figured it out before anyone else did. Just based off her, like,
Purchasing habits.
literally, like, why am I hungry? Like, if she Googles, why am I extra hungry today? Or, like,
It's gonna memorize that.
yeah.
Yeah, I've been looking at Boots, and now I only get Boots ads.
Like
Like
I'm just getting backpack ads and
yeah,
My
yeah,
girlfriend-
it's just
My
like
girlfriend
that.
got a
No,
cat.
yeah, that's the-
My entire feed is cats. I'm not
Yeah,
kidding. I'll
it's
show
not
you
even
right after
useful.
class. I'll show you.
It's like within who you're like, it can track
There's
you, right? And
cycles.
who you're interacting with.
I started
So
my
it's
last
gonna show
co-op
you
job.
stuff
Yeah.
for, like other people's for you.
I
Yes.
started my last co-op job. 2 days later, Instagram recommends that I follow my boss.
No.
I mean Instagram does like this sees
scary.
your follow stuff.
Through the
I got a
contacts,
recommendation
it's
for you today, so I followed.
Did I follow
Yeah.
you?
I have no clue. I don't know. I like follow people as they come up.
Same.
I never asked to follow people because I just
So
like
now
don't
we're
really
getting some sort of.
Yeah, what to do? Such an
Did I
awkward
say yes?
place, bro.
I don't know.
This place is so awkward.
What's
So,
I'll request
start
it now.
again.
Yay!
So usually after you do like 2 or 3, you will start to notice that there becomes a trend for whatever answer you're getting. In this case, clearly the number of terms is increasing, and then each term always has e. So we'll say that there are n plus 1 terms.
That's not part of it.
Um, All have e, and then they all have a as well. So all have a. And other than that, the 0 term has nothing. The first term has x, and the other term has a. So the other ones have x to the power of n up to a to the power of n. And then also for the first term here we have 1, and then for the second term we have 2. For the third term we have also 2. This can possibly be hypothesized as a it's potentially a what's it called, factorial relationship, but we haven't confirmed that yet. So we can just preliminarily represent this as a sum of terms. So the sum of terms from where n is 0 to n. Let's just say I is 0. so n, and then all of them have ae, and then your x can have n terms. So the first one has xn, so we can have xi, and then we can have a n minus I. And then the constant term we don't know yet. So if we were to attempt to expand out even further, we will start to find that it is true that this does follow a n factorial relationship. So now we can rewrite a and e into what they should be. So a should be minus x to that. So we write minus 1, and then this, and then e should just be e to the minus x. Similarly, our a over here, so overall we can have this is a to the n minus I plus 1. So that will change into -1 to the n minus I plus 1 times this n minus y plus 1. It's just like how to expand out something that we don't really know that all about. So this is what we evaluate inside to be. So now, fortunately, also I got the formula wrong. It should be 0 at here. So Laplace is a transform that only really works on the positive side, only because our function that we're trying to transform it with regard to is an exponential decay. So on the it's an exponential decay. So on what am I doing? Sorry. Oh my goodness, my bad. So on the positive end, when x is tends towards infinity, our function e to the minus xx is tending towards 0.
It converges.
So it converges, versus the other side doesn't converge. So there's no use in using the negative end of the transform. So this is an open-ended transform, and also 0 can technically be just any random constant that you decide to put here, but in the standard Laplace transform we use 0 only because then we can standardize our table, because as we said, the reverse doesn't really have a function representation. So now fortunately when we plug it back into the fs, we're trying to take our each term, and we're trying to take this from infinity to 0. And 1 second. So just to be clear, these numbers apply to the variable x. So x is here and x is here. So when x is when x tends towards 0, xi is 0. When x is infinity, then e to the minus xs is 0. So it actually turns out that all of the terms that have multiple powers of x just don't exist, because just cancel to 0. You can imagine that they will all not exist on the final evaluation. And then the only one term where, so I'll just write it out. When I is greater or equal to 0, this case holds. So sorry, my bad. This should be 1. What am I doing? It should be 1. So all terms disappear. Versus when I is equal to 0, our function is when I is 0, we have no x, so x to the 0, and then e to the minus x, and then 1 to the factorial, and then -1 to the one cancels out. Sorry. 0 to the back. Oh my god. That's why it's wrong. Then -1n plus 1, I think. Could be doing this wrong. We'll see. And then this also n plus 1. So what your original power was simplifies to something much simpler. Obviously, these ones are ones. And as we said that when x goes to infinity, this also goes to 1. So it turns out that our thing should be, I think I canceled out some term I wasn't supposed to, because it doesn't match with the table. Sorry, this is n factorial, not I factorial. So n factorial does not get affected. That's why. That's my mistake. Okay. Yeah. And 1 second, why do I have an extra negative term? It's because I have a negative x over here. I'm actually not sure why, because I'm ending up with n factorial of -s to the n plus 1 rather than positive s to n plus 1. So let me just find what a mistake is so I don't teach wrong things. We have a negative here, so when I is equal to 0, that's correct. Does it persist? It does. I'm actually not sure why mine have a -1 to n term that is not supposed to be there. So the correct expression on the table says that it is n to the power of this n. So we're pretty close. Just trying to find a mistake. I think it's encapsulated in A. Should be minus sx. Let me see if we did an example of this. Nope. Did not. Okay, well, I guess I will eventually find out what's wrong, and after the session, I'll figure this out and send it to you guys. I'm so sorry.
It's all good, Josie.
Mistakes. So when I used to play this board game called Hanabi, I would always create a table with a name called Mistakes Land, because just feel like mistakes are such a necessary part of playing a game.
Mhm.
All right. So we did one example of using the initial, using the definition, and we can also do an example where we can use this to solve an differential equation. So to do this, there is a table, which I will just write the necessary ones here. So to take the Laplace transform of a differential, you would take S2 because it's to the second order, and then your original transform minus S1 with your function to the 0 and minus just your function prime to the 0. So similarly, when we do 10, we do Sy and then minus y to the 0 and plus 9 of ys. And on the right hand side, we have 5t. So t is a special case of t to the 1, and t to the n is expressed as this.
Wait, I'm confused. You're just using the
I'm just using the table. Yes. So you should probably pull up the table, or this will be hard to follow. So we get 5 of squared s squared over 1. We can expand out the bracket. You can tell I'm getting lazy by just like trying to not write. So we can highlight all the terms that have y transformed. We can replace all of these with correct things. So this would be -2, and then this would be negative. So I just have a habit of like, whenever I cross something down that has a negative sign, and just write a negative sign up top, because I've made so many mistakes where it's like I just forgot to look at the sign. So make it easier for myself. So now we have all of the terms that don't involve ys. So ys terms are squared minus s plus 9 s, and then plus s minus 2 minus 10 minus s squared to the 5. This is minus 12 plus s minus s squared to the 5. So this would be squared to the 5 minus 12s squared plus s3. So now if we move it to one side, then we get y to the s is equal to s squared with s squared minus 10s plus 9 of minus 5 minus 12s squared plus s cubed. Oh, sorry, we have to move it to the other side, so we invert all the signs. And I think we all remember how to do factor polynomials. So in this case, we would just get -1, -9, plus s. So this would be equal to s squared, s minus 1, and s minus 9. And up top is some sort of collection of that. So when you deal with these massive expressions and you're trying to invert your Laplace transform, what you should do first is to see if the power of what you have on top is less or equal to the power that you have on the bottom. Because if you have equal power, or like if you have, let's say, s to the 6 up top, then you want to take that out of the fraction and write that as like s squared and then minus some fraction. That would make your fraction work much easier. But in this case, the up top is 3, and down here is 1, 2, 3, 4. So we're good. So to write this in terms of a number of fractions, which is what we eventually want to invert, we will want to do our partial fraction thing, where we just assume that you can rewrite this, which usually in most cases you can. And now you would just test out what it would be. So you know that what's up top, currently up top, should be equal to what you have wrote. So this should be s minus 1 s squared b plus s minus 1 s squared b plus s minus 1 s squared c plus So you can do one of two things. He taught us kind of a quicker way, but I'm just going to do it the very traditional way. I'm just going to expand out all of the terms, and then I'm going to match them up with the correct power. So this one would be as cubed minus 9s cubed a, 9as cubed squared, plus bs cubed minus bs squared, plus cs cubed, plus 10s squared c, so minus 10s squared c, and then plus 9s c. And then here we get 2 ds squared minus 10sd plus 9. Just checking. 9D. That's correct. Alright, so now we can highlight all of the terms that have s cubed. Let me just do that so it's easier. So now we know that minus 1 is equal to a plus b plus c. We also know that 12 is equal to minus 9. Now it's just simultaneous equations, which should be relatively simple. And s is 0, so 0 equals 9c minus 10d, and 5 equals 9d. So d is clearly this, and now we can find c. 9c is equal to 10d, which is 9 to the 15. Now A and B is slightly more difficult, but it's definitely not like ultra. So first of all, I would just write this in terms of negative 81, 81. So if we subtract 50 from this, we get 31 plus B. And then this would be 81, 12. So 162 minus 10, so plus 500, 600 here. There's an easier way to do this, which you guys should probably use. But I'm like a pretty old school person, so. 631 is equal to minus 8. Okay, this could be wrong, but I'm just going to check.
What did you see? I got -2 for one of them, so maybe
Yeah, these numbers seem very sketch. So
5/9 I got.
What about
Now I'm
C?
lazy to do the rest.
okay, so I'm just going to attempt method 2, just because when it's such a long thing, it's very easy to mess up. So
Yeah.
method 2 would involve setting s equals to 0, let's say, just pick any s that arbitrarily exists. So now we get the only terms that don't have s is 5 on the left hand side. And then A has a lot of s, B has a lot of s, C has a lot of s, so only D doesn't exist. So this is minus 9D. So there we get D is equal to negative. Right.
Why are you doing -1 times -9?
Because in the equation, this goes to 0, this goes to 0, this goes to 0. So the only thing that doesn't go to 0 is the D term. The D term has just -1 and -9.
Oh, I see that. Okay.
Wait, so why is D equal to -5/9?
Because I made a mistake originally, and it's supposed to be 5 equals 9D. In which case, oh fuck, no, I didn't make a
Yeah,
mistake.
5.
Oh my god. Okay, so I think, okay, double checking important. Double checking very important. On the exam, definitely double check. I would highly recommend that. So in the s equals 1 case, only a still exists. So it's 5 plus 12 minus 1 equals -9, 1a. So on the left hand side, we get 16. On the right hand side, we get -9a. So a is going to be -9/16. Yeah, I think this is probably more correct in this case. Yeah.
4/3.
Hmm?
A should be 4/3. Like when you reduce the.
Oh yeah.
Yeah.
Yes. Yeah, so I don't know what mistake I made up top, but seems like definitely important to double check. So 5 plus 12 times 81 minus 27. -81 times minus.
A, I think.
Which, what is it? Over.
Oh, A is over S subtract 1.
B is really unhelpful.
He's just not great.
Yeah, it's not happy. So awful. So on the left hand side, we get
I forgot we're not allowed calculators in the
Oh,
Can do mental math.
I was just saying.
We're doing 27 times 9 on by written out on the paper. Everything.
so on the left hand side we get 248
On division as well.
and equal
Me doing 2 plus 2 just to double check.
Yeah, on my calculator.
Literally. I mean, okay, the thing is,
Maybe
that
they
that's-
changed.
I screwed up it. Okay, I caught it before I submitted it, but like the assignment, I got the wrong answer because I screwed up like 2 plus 3. Like Amanda's looking at it, she's like, yeah, -2
so now
plus
we have
3
to
is
just pick
not.
something random,
On the midterm,
I would probably just pick
-1
maybe,
And I put
or
A
maybe
equals 3.
that would make C easier.
I was like, no.
Yeah, let's pick -1.
Just like white out the parts you don't want to answer.
Yeah, like.
It's like when you're not sure if the answer is a 3 or a 2, write something in between and hope he guesses. Make
Yeah,
him
make
guess
a 2 look kind of like a 3 and be like, oh, that's what I meant.
Totally meant.
whatever he marks. You're like, no, I meant the other.
Yeah, like, look at it, it's clearly in one, like SN5.
That like tail is supposed to.
I'm gonna mess it up on the final, like my S's and 5s are gonna look the same, I'm gonna mess up a lot last because I swear it's gonna happen.
Yeah. And just,
I'm gonna mess up because I'm gonna forget what probably last week.
248 for 648.
Yeah, wait, what's that like reduced?
Oh yeah, sorry, I didn't do that. Yeah, so 248 we can take out 8. So we get 31. 648, we can also take out 8. We get 16.
Okay, maybe we need like a calculator.
I don't know if I can.
I don't know either. I'm gonna use like an apple.
Left hand side
Yeah,
we have
but it's
18.
gonna give me.
We have minus
Oh.
10.
I'm trying to get it so like
31/81.
31/81. Yeah, it's still ugly, but it works.
Minus 2.
You can pretend the one's not there and it's close enough. You know.
And then we can minus 20c plus 20d. And d is so now we get an expression for 20c. 20c is minus 18
What's the point of not having calculators?
plus our 900. So at this point it becomes slightly monstrous.
Just a little.
So the thing that you want is 61 and 9. I mean, isn't this like elementary or middle school?
Yeah, but I haven't had to do this
It's a
since
lot,
elementary.
Oh, okay, no, that makes sense now.
It's just time consuming.
How about we know how to do it now, right? We can skip it.
Okay, I always think that about completing the square, but then I go in to do it, and it's just like, wait, what the
No, I know I don't know how to complete this here. That I know for sure. I know.
Our Stokes theorem is just the math version of Gauss's law, right?
I've never used Stokes theorem.
Stokes theorem as well.
Is just the math, the vector calculus version of Gauss's law.
No, Stokes theorem has to do with the curve. Gauss's theorem. has
So
to
it
do
seems
with
like
the
I've just picked, unfortunately, a bad number. But fortunately, we did this twice, so we can pick out just only the useful information. We can do D is definitely correct because both of them say so. I think C for B, this is more likely to be correct because the calculation was simpler. And then for A, we also found a pretty close value,
I got -2 for that.
negative
No,
2.
you messed up. I did that the first time
Yeah.
too. You just put 5.
And then because C over here is simpler, I'm just gonna say that this would
Yeah, I
be
did
likely
exactly
to be
the
the correct answer.
Because I also got -2 the first time.
What
The left side you messed up.
So
Press
I'm just
plug
going
in
to
one into the
put
other
that
side.
out to the side.
You did?
Yeah, so I suppose on the test, knowing 2 also makes it so that if you mess up one, you can still use the other as a backup, which is pretty
No,
nice.
I don't think he would give us this.
No, he
It just takes
wouldn't.
like a lot of time. Like,
Okay.
Unless it's the entire exam, which I'm still expecting him to only put like 2 questions on there because he's kept talking about it in class.
No, he said he's putting
9.
8 or 9.
I feel like he's lying to us also.
9
though.
No, I think it's reasonable. We had 6 on the midterm, right?
I think so. I
What was
failed the
it?
midterm real bad though.
One sheet.
D is 95. Okay, so we should all remember how to invert the Laplace transform. So this would just be T, this would just be 1, and this would be T to the negative. So it would be E to
It's
the
getting dark.
It's gonna be dark
Right.
soon.
It'll be dark probably near like by 5.
If you step outside
Chemistry,
now,
do you
you
think
can
I
enjoy
should
the
try
last 10 minutes of
I think so.
So now we got this.
Yeah,
We
it's
got
like
y
440.
is equal to negative 3/3 et plus 6131.
You should pull the chair, Jesse. You've been standing.
Yeah, do you want to get a chair? There's some chairs over here. Oh, they're kind of shit.
It's okay. They're okay. I'm gonna be all right. And standing is just an exercise, you know? Excuse the exercise. All right. So ideally on the test, what you would also do is to plug this back into the original to see if it is correct. And I would really, really highly recommend doing that on the test. But because this is just a practice, we're not going to do that. You should do that. 31?
Isn't B 31 over 81? Like, check your.
I think you wrote your 6 weeks.
No, it's 31 over
Wait,
6.
Oh, sorry, it's
According
81.
to
81. 31 over
Okay,
80.
yeah, thank you. Appreciate it.
Jesse.
But I also type things in wrong most of the times. I don't know.
All right, so we can move on to some of the other problems. The other problems that you might come across involve using applying series solutions
Oh, yes.
and applying system solutions. So this one you would decompose your original multiple order differential equation into singular order differential equations and solve them simultaneously. So just to remind you how to do this, for the lab, you might have done this many times already. Just going to pull up the question over here. You can do.
Are we actually gonna do that last time?
Yeah. I
Oh,
want.
did you start system?
Just
She's
No.
talking about it now.
Okay. Just in
So-
time. Perfect. That's what I came for.
Do you think you can make us actually solve matrices?
simple ones, yeah. I think maybe like 2 by 2. I think is okay, right?
Oh, okay.
He said 2 by 2.
Yeah.
Oh, really? For nothing.
Well,
He
because
said
then it's
he
out of
won't
the
make
scope of
us-
the course, you know?
Yeah, he said he won't
Yeah.
make us solve anything that's not 2 by 2.
So
Okay, I'm happy with that.
so similar to the labs, you can rewrite the second order into multiple first orders. So if you give yourself two of these, right? If you give yourself a matrix of two of these, and if you were to take not the transpose of the matrix, but the derivative of both of the terms, this would become y prime and y prime prime, right? So that's what you want. You want to figure out an expression for y prime and an expression for y prime prime. So y prime would just be y prime would just be you get y prime, and then y prime prime you can find from your original thing. So you would say that this guy is equal to, so you just want to isolate it, that's all. Now y prime prime is -2, 5 prime plus 2, 3, y. So what you can do is write this. So if this was in a lab, you would represent y prime as the second the second row of the vector, and you would represent y as the first row of the vector, and you would put it in your program, and you would be done. But instead of this, we're just going to write our thing in terms of, so let's not use y and y prime, just name them some random names. So I will just give mine the number just m and n. So in this case, my m is y to the prime, and in this case my n is m to the prime, and this will be y to the prime. So now you can also, if you align this together, let's say that I'll move this term to the back. So put this in the front, put that at the back. Right. So you notice that it's a linear combination of y prime and m prime, and linear combinations can be expressed as matrices. So you'll just be like, okay, I put one part of y prime. You can just make a table, actually. That would probably be easier. And then 0 part of m prime for m prime. And then for n prime, I put 2/3 of 3/2. English fractions suck.
English fractions?
Yeah, fractions in English really suck.
What's fraction in another language?
So in Chinese, it would just be like,
Mhm.
literally be like 5/2.
I use slashes too in my writing, yeah. See, I find it easier than one top of each other.
Yeah.
Space efficient.
No, but it's like in English, right? It's bad.
You could just say 5/2.
Okay, fair. It's probably easier. So now you got your matrix, right? And what you would put on the side is just y prime and n prime. Or rather, what you would put on the side instead of y prime and n prime, because this is just m, this is just n, we'll put m and n. So you notice how we've converted m and n, the operation of taking the derivative, into the matrix that is being applied to it. So both sides have the matrix m and n. This is great because we know that we've essentially applied some matrix to it and yielded some sort of function. So we can essentially say that this guy is the matrix equivalent operator, is the matrix equivalent derivative operator for this function. In order to solve this, we will want to
I'm getting a little lost. Yeah. So m is y prime.
yeah, n is y prime prime.
M is y.
Sorry,
prime.
so m is y, this is y prime. So on the left hand side, this is y prime and this is y prime. He
Why-
used x1 and x2.
Why did you write for the bottom row? Why is it 3 over 2 y prime? Isn't it just y?
Oh yeah, I was wondering that too.
Wait, I'm confused.
No,
So
because
you isolated for y prime prime, and
Oh, my bad. Yeah, no, sorry, it should be reversed. I should be reversed, my bad. So, this is y, and then this is
no, it should
y
be m prime because m is y, right?
Yeah, it should be
So
m.
should that be n or m prime? Okay. That makes more sense.
Yeah, my bad. So the matrix is reversed. I'm so sorry. I swear, like, when the course was going on, this was easy, and then now it's like, the course ended.
it's just the
Suffer. Stop.
too many equations. Like too many y is that and then n is that.
Oh, okay.
Just get
Wait,
lost
why are
in it.
they?
My bad. Okay, how about I try something else? I can try, yeah, I'm just gonna look at these. When he was going over the section, it seemed confusing as well. But
Yeah.
I think the main takeaway is that you want to get it into a form where you can represent your original equation as multiple references to itself, and then let's see how he did it. Okay, so this seems fine actually. It's not that bad. I think.
Oh, this was the exact example.
Yeah, that should be
Okay.
just checking to see if there's anything I missed. Yeah, no, I think this is okay. It's technically fine. Oh yeah, I think I put okay. I think I just put M and N reversed. That's all, because of making this previous mistake of swapping. I should actually swap the entire rows, not
Do you
just.
mind if we just redo it?
Yeah, okay, let's redo it. That's probably
So this actually matters. It's not like just as long as they're consistent, it's fine.
no, it actually matters.
Okay.
It actually matters that you put prime on top. So I'll just start again. We'll start with y prime is the. We'll start with the derivative of y is y prime. And then we'll start with the derivative of y prime is y prime prime, which from our original equation we can convert, and this equals negative 2/5 y prime plus 2/3 of y. So now we can write our matrix in terms of just, okay, I will rewrite this in terms of the dy dx in terms of y here. Right, so now we get dy x y prime like that, which is equal to some matrix of y and y prime. So to put the correct things in order, we will want to write the table again. So y and y prime. In the first row, we have 1 of this, 0 of that. In the second row, we have 3/2 of this and negative 5/2 of that. So now we get the that was a good suggestion. This is much better. Okay. I hope this is understandable at least. Okay, good. Eventually, we're doing this. All right. And now we realize that what we've created was a way to represent our derivative in terms of a matrix equivalent. And to invert our derivative, we can just invert our matrix. So to invert a matrix that is two-dimensional. Oh, sorry. We want the solutions. My bad. We want the solutions to a matrix. So do we remember how to solve a matrix equation? Just anything like that?
Just like.
This one?
I mean, an example, you took the determinant, and
Yep.
then,
So
and then you
here's
take each of the eigenvalues.
yeah. So here's how to solve the matrix. You will first decide that this is the thing that is a square matrix, and you want to take the determinant of your matrix, which is, let's call A, times the identity matrix minus A minus the identity matrix times some sort of lambda. And then you will find that your lambdas happen to be your eigenvalues. And 3, you will substitute lambda into the original for your eigenvectors. So first, to take the determinant, So take the determinant. To take the determinant, if we remember how to do that for two-dimensional matrices, so I'll just say A, B, C, D for simplification. It's just AD minus CB. And then what an identity matrix is it's a matrix where the diagonal elements are all 1 and all the other ones are 0. So it would look like that. So an identity matrix of lambda would be lambda, lambda, 0, 0. So to take the determinant of our A minus I lambda, we would put our matrix into minus lambda like this, copy down all the other values, and then minus 5 to minus lambda. And the straight line denotes that we're taking the determinant. So it would be minus lambda minus 2 minus 2/3. This will be lambda squared plus 2/5 lambda minus 2/3. So from this we can find our, if we say the determinant is equal to 0, we can find our roots to lambda. And this equation is called the characteristic equation. Now we can solve this by using pretty simple things that we've already learned. We should be able to solve a equation like this. So it would just be -1, 1, 2, 3. So we get lambda is equal to half or -3. Whoever will be able to remember how to do a differential equation in like 10 years from now, I will take you for a trip.
Yeah, I won't. No way.
Don't ask me 10 years, ask me 2 years.
And I still maybe not. Oh, remember.
Yeah.
Ask me tomorrow and
Literally.
still might not be.
Like
You know what?
10 minutes
Ask
after
me
the
now.
10 minutes after
Yo, bro,
the
the
session.
spice is still fucking.
That sounds awful.
Ask me right
My
now.
throat's so fucking.
It's like you really don't know what you're doing.
Yeah.
The biryani, 85%. Yeah.
Alright, so
He did like 10%.
You?
If I drink milk helps.
Yeah, I know. I'm excited to go home and down a liter of milk. Oh, choco milk goes crazy, guys. Choco milk goes crazy, you know?
Absolutely.
Bro, especially on the
So
weekend
now-
when you're just like, you're not making rational
Just a
decisions.
question. How did you do the factoring?
Just go buy like a $3 liter
I
of
don't know the
choco milk
trick.
and you just drink it like it's water.
It's like you kind of look at like anything that can multiply to
Of
make
choco
2,
milk?
so it's 1 and 2,
They
and
have
then you look at
bags?
whatever multiplies to make
Choco milk?
-3,
Yeah, they
so
have
it's
really
-1
bags,
and 3,
I
or
have
-3
two
and 1,
pitchers,
and then you just multiply,
Yeah.
cross multiply them and see if they add to make 5.
Yeah.
So
Guys, I had these, I had these.
2 times
He
8
knows what's
equals
up.
6,
We can
-1
catch up.
times
He's living
1
in the
equals
future.
-1.
Yeah.
Those add to make +5.
the trick is that
Also, I feel so unwell. I don't know if I
if
can
the
walk
middle
home.
number
Oh my
is
god.
large,
Dude, I
if
live
the
big,
middle
but it's
number
so-
is large,
Yeah,
then you have to
honestly,
pick
I feel
numbers on the
exactly
sides
same.
which
Yeah.
is like
Let's
1
see,
and
bro.
something
Well,
else.
that would fuck me up.
And specifically, if your number is
We should have
large
got
and it's
shawarma
1 less
plus,
than
So I
the
want plus.
product of the other two,
Or
Uh,
10.
one of
We
them
should
is
just be
negative,
white.
then it will work out.
Nah, no,
And if
I'd
it's
rather Auntie's kitchen.
1 too much than the product, and both of your sides have the same sign, you're also
Yeah.
okay.
Say that
So
again.
now we can also find the eigenvectors. Did you guys do this in linear algebra?
15.5.
Plus
Did you
Eigen
not take it
stuff?
with us?
25.
Yeah.
It was the last thing though, and I literally went through them.
Oh,
The eigenvalues?
I went to the
Eigen-
exam with no
eigenvectors.
58.
Do we need to know how to find the eigenvector or just the
Me
eigenvalue?
either. I did so bad on
Should
it.
know
Not
how to
I
find
had
It was on mine.
seven,
So
like,
lambda
For this
is
one, I don't
the
know
whole
shit,
thing.
but for the
Yeah.
DVPs,
Yeah.
eigenvalue problems with eigenvalues, that one's also really easy. There's just use false notes.
all of them?
Yeah,
I still haven't done.
yeah,
like,
I know.
the
I'm
practice
fucking
problems.
annoyed
Some
too.
of them are, like, introductory.
Did you get breakfast?
And I need to do it.
That's the 16.
Paul's on mine.
So when you plug in one of the eigenvalues, you will
I'm-
figure
I'm
out
not
that
happy about the
your-
standard verifier.
Is that including the column?
Yeah, the rest of it.
Yeah, that's not.
And
Wait, is the session over? I'm confused.
I don't think so, but if you want to go, I think we're done. I think you just practice questions after this, right?
Well, it's almost
We
done.
have series.
Oh, series. I
solutions
forgot about series.
And systems. Sorry, it just ran a little
Okay,
bit over
Matt,
time
with-
because we started late and we took a very long break.
We did take a very long break. It's our fault.
So it's gonna be a while.
How much are you at before?
So what you should do
76,
after you find your
75.
eigenvalues is that you should find
Of
that
655
you have two rows that
for the
um,
day.
is some factor of each other.
4:30.
Your rows have became dependent upon each other, and that's what you want. So
that's
now you
the
want to
goal.
express the relationship of how to get between these two values. So let's arbitrarily say that one of them up top is like negative half of x, let's say. Then how do we make that 1? We can make that 1 by saying we take
So
How do
make
you
that
know
1 by
that?
saying
How
that
do
we're
you
going to
know?
take the
Okay, where's the website?
sorry,
Okay.
going to make this x. So this will be just 1x. And then to make 1 out of negative half, we will take negative 2 times x, which makes 1.
Could you explain that a bit more?
Yeah, so what your eigenvector is it expresses the relationship between the items in the same row.
Oh,
So
Jesus.
if we say one of them is x, then the other one will be. Let me just make sure this is correct.
with another.
Yeah, I think it is correct. An alternative, you can. Okay, actually, I think the one that he did on the course notes is slightly easier. Let's do that. So let's say that you're arbitrarily putting this with alpha 1, alpha 2. And your eigenvalue and your eigenvector is just alpha 1, alpha 2, right? So if this must equal something, just take the top row, multiply matrix, you get minus half alpha 1 plus alpha 2. We're going to say this is 0 because it's an eigenvector. Yeah, actually, this is last mistake from as well. I think I did it wrong the first time. So now your alpha 2 is just half of your alpha 1. So therefore, your alpha 1, alpha 2 relationship is half of 1. No, that is also wrong. Holy shit, what am I doing? Holy shit, what am I doing?
Yes, it is. Cool.
This is so awful. I'm so awful at this.
You're doing great.
No.
Like, if you look at the solution he did in the notes, like, he kind of solved it like that.
Let's see.
And it should be 2 over 2 and then 1, right?
Definitely so.
Yeah, that makes sense.
Because then you get y prime equals
100.
or like
This? Wait, sorry. 2.
and then
I have the assignment here with the exact same question if you'd like to look at it.
Yeah, I'm looking at it here, but I'm trying to figure out why. Oh, okay.
yeah, there's just
So
2
what we want is like 1 times. Okay, so the idea was correct the first time. We want 1 times of alpha 1. And we want some number of alpha 1 for alpha 2. So I think the idea is there. Okay, I'm just gonna do the other one and see if it comes out correct as well. This is scaring me because I'm like, oh, I for sure knew how to do eigenvalues and eigenvectors, but no, I totally do not. Okay. So again, these are dependent upon each other. We want to express the relationship of these two, so we arbitrarily decide that we want to take a linear combination of them.
Was the matrix just wrong the first time?
Yeah, it was wrong the first time because I forgot that you need to do the negation. So that was my bad. Okay, so we decide to take a linear combination of the two to find out the relationship. And the linear combination works out to be 3 alpha 1 plus alpha 2 is 0. So now we can express alpha 2 in terms of alpha 1. And we can get 1 times alpha 1 on the top and then negative 3 times alpha 1 on the bottom. So the eigenvector that corresponds to a half is going to be 1 half, and this one is going to be 1 minus 3. So now, notice that in the original equation, our matrix served as a linear operator. So similar to the previous idea that the exponential function linearizes the derivative, we also found the operators that the values for the eigenvalues, which allows us to linearize our derivative. So now we would just take something like our x, or rather our original thing we were trying to solve, which is y prime, would be equal to e to the half of, let me just make sure that's correct though. What the hell is that? E to the half of x. And then its eigenvalue, so its eigenvector, then e to the negative 3x, and then its eigenvector here. Taking a linear combination of these two. So basically, we were trying to figure out the components that make up this matrix, which is equivalent to taking the derivative, and we figured out that it can be expressed in terms of the eigenvalues and the eigenvectors that are below. So now we get our thing. So to find out what y of x is, you can just read from the first line. The bottom line tells us what y prime of x is, which we're not really interested in. So we can just get this value. Okay, enjoy, have fun studying.
Bye. Bye.
So in the original boundary condition, we had this. So we can write this as y prime at x is 3 is equal to 6 and negative 1. So we should get 6 and negative 1 over here. So this at x is equal to 3 should also give us 6 and negative 1. So for this to happen, it's going to be a huge complication over here. Yeah, this is the really unpleasant part about matrices. It's just like this AND computation. That's super annoying. Did he even go through that? Just checking.
I think it was a lot easier because we made it 0.
Oh,
So then the e's was
okay.
just 1. So then it was
That's fair.
literally just
There's
two
one.
equations where you subbed in.
Okay. So we can do one where it's 1, or we can do this. We'll just say that you will need to find a and b, and then you will sub it into the final equation, and then read from the first row. But you kind of understand how to do the matrix solution, right? Or at least I kind of do now a little bit.
Yeah.
Yeah, it's making a
It's like there's a lot of places where I can mess up, but like the general
Yeah.
concept I understand.
Like literally,
you know,
like, I
I
messed
agree
up so many times right there.
Like I might just flip the numbers by accident or write the matrix, so like I flipped it by accident, but like the general concept of how to do it makes sense.
Okay, guess we need more practice on that later.
Yeah, but that's like a next week problem.
Yeah. That's like the day before the exam.
Yeah, you know?
Oh my god, okay. Do you guys feel comfortable with finding series solutions?
I think that one's like, we can review.
That one's there's only one way to do it, right?
Yeah.
It's like you find AXN, right?
Yeah, like
And then you
I
find the
just have
derivative of that. And
one
then you do it.
example
Yeah.
over here where you can find a series solution around
solution for differential equations?
x is equal to -2. We can do that,
Okay.
and we can also talk
Yeah,
about.
I'm surprised you finished it, basically.
I just.
Like,
This
it
is a
looks
long
this
day.
big, and it's like super spicy.
Or B,
That's like
series solutions. And then,
Are boundary value problems really something like separate that we really need to like go over separately?
So there are only a couple of discussions
like, yeah.
surrounding this.
Just more
Um,
like concepts and calculations or?
Yeah, this just has like 3 lines of notes that I wanted to go over, and that's
Okay.
Good
So,
oranges.
let's take the example of this, right? Which you already know the solution to.
Oh, these ones are so fun.
it's
This was the one that we went
To
over
the-
really early yesterday.
It's n. So if
square root of lambda somewhere.
if n.
A.
Sorry, I'm so hard.
Yeah, yes, indeed.
So this is the one that we went over yesterday where we can linearize as a function of.
This is when delta is greater than 0, right?
This is when delta's less.
Which one is it? That's what I'm asking.
Shouldn't be less than because there's like it's complex.
Well, you have to do all 3, don't you? Every single time this is asked.
It's always less than, so delta is always less than 0 in this case, because we're assuming that in this case, I'm writing this general thing where I'm assuming that lambda is a positive real number, or at least non-negative real number. I don't know if that makes sense. So the reason why I have to specify sign over here and over here is because I don't want this to be to be mistaken for the other case. So only delta less than 0, only determinant less than 0 is a valid oscillator. So if you
Oh,
remember
right. It's underdamped, right?
that, yeah,
Yay.
there you go.
Overdamped is
I mean, it's not damped at all, so it's very underdamped.
yeah.
So, just a couple of conditions, such as you can have y0 is 0, for instance, which would necessitate that your a cos of 0 plus b sine of 0, because sine of 0 is just 0, it necessitates your a to be 0, right? So you understand that makes your solution just in terms of b sine of lambda x. And now, if you were to apply an additional boundary condition where, let's say, you get you give y 2 pi is, let's see, 0, right? Then you get that, shit, I can't. Then you get that
Well, your computer's camera's working.
your y of 2 pi is 0, which is b of sine of lambda 2 pi, which is the same as being 0. So your b is just any real number there is. Versus if you were to have a second boundary condition where, let's say, your 2 pi is equal to, like, let's say, 3, then you have to somehow make b of sine 0 3, right? Sine of something 2 pi, which is equal to sine of something 0 3. So you understand that sorry, my bad. What am I doing? Yeah, sorry. So in this case, no matter which lambda it is, this has a solution for all lambdas. So we want to figure out for which boundary conditions, what values of lambda will be true, will be solvable. So this is just a description of that. If we were to, let's say, put 3 of 2 pi over here, I'm so sorry. I'm having so much trouble explaining this, and it's a bit late. So
It's okay. We can probably go through a lot of this on our own as well because I think there's good documentation for.
Yeah, I think it was mainly
yeah, I think
just-
this is good.
This one's
Yeah.
this is easy
Like-
to learn.
Yeah, like this is compared
Okay.
to like Fourier. Like this is
Compared
not
to
a problem.
Fourier, yeah.
Yeah.
Like everything compared to Fourier is
This
fine.
this is literally the same thing as initial value problem
Yeah.
with one extra step. Like
Yeah.
So
inherently.
okay, so I'm just going to end it here, I guess.
Thank you. Jess.
I'm so sorry. I literally like died today here.
No, it's
No,
okay.
we were
Thank
following
you.
you, bro. I feel like I could really follow along. Like I didn't feel like
Okay.
lost,
Made sense.
that lost.
Signing off YouTube. Thanks, Amanda, and
Like
whoever
and
other was.
subscribe.
Like and subscribe. Oh my God.
What are we calling our
Comments.
Amanda
You know how
says
the
thanks.
algorithm works. You gotta watch till the end and then comment.